Hello, welcome everybody. Thanks for joining us for today's presentation with Intel titled Flattening the Grid. Before I introduce today's presenters, I'd like to just cover a few housekeeping items. This webinar is being recorded, so all participants are on mute. We do encourage you to ask questions though, and you can do this by using the Q&A button at the bottom of your screen. We're going to do our best to get to all of your questions at the end of this presentation, but if we can't for any reason, we will respond back to you offline. Giovanni, if you'll hit the next slide. Your presenters for today's webinar today are Joe Jankowski and Prithpal Kajuria from Intel, along with Giovanni Polizzi from Minsight ACS. Joe brings together partner ecosystems to solve utilities' greatest challenges, to optimize their infrastructure for data intelligence, gain greater insight into grid operations, and drive new sources of revenue. Prithpal works with the ecosystem of equipment manufacturers, automation, and software vendors, as well as utilities and service providers to develop and deploy connected devices, edge platforms, and cloud architectures for operational excellence and transformative businesses. Giovanni is an energy enthusiast collaborating with the energy sector to shape the utilities of the future through digital transformation, application of IoT, and the blockchain. He's consulted internationally on IT systems and business process transformation for the energy industry in areas like smart grids, transactive energy, industrial IoT for utilities, DERs, and conventional power generation. With that, I'm going to hand it over to Joe to start today's presentation. Joe, take it away.
Thank you, Delana, and good morning to our audience. I'll start with this next slide here called The Great Energy Transition, Flattening the Grid. And when I talk about that phrase, let me break it up into two different concepts. First, I think we can agree that the energy world is transforming. If nothing else, think about the shale revolution that shifted generation from coal, the rise of wind and solar, the coming wave of EVs and storage, and last of all, global carbon reduction mandates driven by climate change. Now, these same factors are transforming utilities as well. Let's go to the next slide, please. And we get something like this. The old business model is represented by the blue swim lane above, where going from left to right, generation, transmission, and distribution, customers, energy just flowed one way. And the new direction can go the other direction too, from right to left, represented by the yellow swim lane here. Here, the consumer of electricity can also be a producer, hence the term prosumer, and send energy back into the system while not using as much of it as before. And this upends the players upstream with power delivered at different times through different channels. And of course, it's all new. It must be cleaner too. This transformation also creates new business models. Think of community solar, autonomous EVs, demand response provided by Google Nest, as we can see in that picture in the lower right corner. And these are just some of the players. Let's look at the new energy supply chain in the next slide. Now in this slide, most of the blue assets or participants are long established. Across the top, we have power generation, transmission distribution, substations, consumption. Again, that one direction. The newer participants are mostly in orange here. You have renewables, storage, commercial EVs charging at businesses and shopping centers around the country and the world, microgrids, smart buildings becoming increasingly more popular, grid-connected buildings. And you have all these other sorts of load shifting mechanisms, let's call them. And those new participants are only growing, and they'll increasingly make the decisions in how electricity is not only consumed, but also generated to meet their needs. So the question here today is, how do utilities respond to this new energy supply chain? And really, it means implementing new technology, the addition of new hardware, devices, platforms, and applications. As the list on the left illustrates, these additions are being made everywhere from the data center to the utility technician in the field. Now, what do these components of grid modernization enable? Well, the answer is that they really allow us to gather more information from more sources in more detail and with less latency than ever before. And in return, we can make decisions and exercise control of assets at the edge that weren't really possible before. And these decisions to control assets like those on the right, to address the intermittency of renewables, the proliferation of EVs and batteries, commercial loads that can change on a dime, and the distribution system connecting them all. And we see the substation at the center of all these devices, platforms, and applications. It's really a critical connection and integration point to create that so-called mini data center on the utility's edge. So now we can see that we can have a mini data center in the substation. So what's that enable the utility to do? Let's look at the next slide, please. And this is a well-worn phrase, but it really is all about the data. And it's not just the utility industry that this applies to. It's every industry and frankly, everything, from our homes to our cars, to our workplaces, to our retail establishments, to street lights and cities. And it now everything looks like a computer, and it's all generating these staggering, in relative terms from what we had before, volumes of data. And that's just a consequence of having all of these devices on the edge, what we would call IoT. But the real problem is that the data only has value when it can be utilized and turned into actionable insights. At Intel, I talk to customers from every industry who tell us that they are literally drowning in data. And as a consequence, they don't know where to start. And to add insult to injury, many of them tell me they are spending millions saving it all in the cloud until they do know what they can do with it. So what's the solution? Let me introduce you to our next speaker, Giovanni Polizzi from Minsait ACS. Giovanni?
Thank you, Joe. Thank you very much, Joe. So before I kick in with my presentation, welcome to everyone who has joined us here. Before I kick in, we'd like to ask you a question. There's going to be a poll, so you're going to be able to give your opinion. So which of the following is transforming your operations? And we kind of identified 5 possible answers in this. Distribution automation would be one, peak demand management will be the second one, integration of renewables will be our third answer, and then integration of distributed generation, or none of the above. It's a way of interacting with you to try to understand what our audience is more looking for in this presentation. So you have some seconds to answer, and then we'll have a look at the outcome of the poll. You should be able to vote on your screens here, and then we'll see we'll comment on the results. We'll shortly comment on the results.
All right, Giovanni, I think we've got most of them in now. I'm going to end the polling and show the results.
Okay. Thank you, Ryan. So, of course, we have the highest being distribution automation. We see there's a lot of interest in distribution automation. The second is peak demand management. That basically is following a bit the idea that we had put into the numbers. Distribution. So we're going to see in the next example what we can do with distribution automation, especially also with peak demand management. So let's move on to the first. So again, another question, but in this case, just to introduce the topic. So how can we get hold of data from the field? So Joe introduced the topic. There's a lot of data coming to organizations. Utilities are no different from others. They're receiving a lot of information. So how can we get hold of data from field in real time to perform a thorough analysis and support grid modernization? And this is going to be the topic of this. So we we're presenting here one-side utilities. We say the solution is here today. Actually, this is a platform that we have developed, and you see at the bottom of this slide there is the logo Intel Market Ready Solution, because one of the two of the solutions that we're going to present in this presentation are Intel Market Ready Solution. So this diagram is basically representing the way data flows inside in a utility. We have physical assets, and we're talking about this lower level here. Physical assets there represented by the physical world. In this case, we represented a panel, but also a substation. So everything that is in the field for us is a physical asset. And we connect to the physical asset through edge nodes. At the moment, let's leave it like this, then we'll explain better what edge nodes are. But basically, edge nodes allow us to do data collection and data processing, but also allow us to connect the physical asset with a digital one on a higher level. So at centralized level, we have data storage, we have analytics, we have visualization of data. We have interfaces, we have the administration of those interfaces towards other systems, and we have the management of the edge nodes. Of course, when we start to deploy hundreds of thousands of these nodes in the field connected to, for example, distribution automation devices, or connected to your existing assets like transformers, for example, relays, then we need to be able to monitor what is happening. We need to be able to understand what software is deployed on each one of these edge nodes. On a higher level, we have the application layer. This is a layer basically that uses the underlying capabilities provided by the platform. So if we store data in the platform, then the application use this data. And this is very important because we can have applications that use data from different data sources. What we see today is very much a system which normally is vertically integrated. You have your data coming from, for example, manufacturing system. So system provided by manufacturers of physical assets. And that's normally in the silos. We want to break those silos. We want to bring that information across different systems. To do this, okay, we built all the storage, and then we have the application layer. And last but not least is the interfaces. We want to have interfaces with existing system in the utilities, with operation in the back office functions. We draw these interfaces basically go down to here, because every one of these layers can actually be managed through interfaces. And this is very important. So data can be accessed at different levels. Edge nodes can be connected directly to the cloud, for example, to cloud applications, or directly to one of your operation system, and have a direct connection with that. So a direct command, for example. So as we go from the physical assets towards the higher level, we of course increase the centralization of functionalities. Whereas as we move from this layer down here, we're increasing the granularity of information. So we want also always this balance, a lot of granularity, so a lot of detail, but then we have also an increasing capacity to accumulate data and to elaborate this data. And now we move into the three use cases that we are going to see today. One is the flexible demand. Again, in this case, we have connecting heterogeneous assets, and we have to offer control and management capabilities. Very important is the concept of heterogeneous assets. So this is a solution that, first of all, is a solution for a brownfield. So whatever is in the field, we want to connect to, and we need that capacity. Demand is made flexible, so demand is not anymore something that can be only taken as it is. We can basically control demand, and then we want the participation of each flexible load and each DR, and want to compensate that participation according to the service provider. And we will see what we mean by service provider. Then we have flexible microgrid, again connecting heterogeneous assets in this case, to offer control and management capabilities. And then we have microgrid that can be run either to support the existing grid, or can be run as an island, for example, under extreme weather conditions. And then the last piece of the last use case is going to be asset monitoring. We want to be able to connect the grid and to monitor their operation to identify out of design situation, for example. And not only the grid owned asset, but also your commercial industrial customers. So energy intensive assets can be managed, can be monitored, and valuable information can be provided to your commercial industrial customers. And one important thing, we're able to understand asset health by mixing real-time information with historical data. This is a new field of investigation, very traditional, maybe in the power generation, but very new in the grid on the distribution, the distribution field. So jumping to our first use case, flexible demand, we identified 4 main functionalities to manage flexible demand, and you can see them in the diagram, also in the writing. The first one is connectivity and characterization. This is what we are saying, connecting heterogeneous assets. We have to be able to understand the availability of these assets. We have to understand the response to the response flexibility. How fast can they participate in a demand response event or in a flexible demand event? The second functionality is dispatching. We put it into parentheses from scheduling because we expect that the distribution utility receives a request for one of this intervention from a higher entity like an RTO or an ISO. So the utility must be able to receive this request and to plan every single connected asset, but also to manage large numbers of them. For example, through the integration with third-party clouds that manage maybe a number of energy storage devices or other devices that are connected to the network. And again, we have different interfaces here depending on what we are connecting to. While a flexible demand event is going on, the utility must be able to analyze, so understand the effects on demand, analyze the localized effect, what is happening at nodal, so in a nodal analysis. And they must be also able to do short-term forecasts because an event may last 2 hours, 3 hours maybe, and they need to understand what is happening in the next half hour, depending on the capacity of all the assets connected, all the DR connected. We represented here solar, represented here storage, but also generation, for example. So by monitoring and understanding if there is some issue, for example, some of the expected availability of a battery is not there anymore, we lose some of the connection with one of the devices, so we have to replace that device with the capacity with another one. All this is done by a functionality which we have gathered into the word analysis. And then there's just rewarding. What happens afterwards? After an event, rewarding availability, just the fact to reward the DR just because it's available. Reward flexibility. So depending on how fast they can do an intervention, do I have to call for the event 2 hours before, or can I call for the event half an hour before? And then the reliability. Has it been connected throughout the entire event, or did I lose connection? So is that connection to the communication channel reliable? And then the contribution. Can they contribute only energy, or can they contribute also KVA? All these are the 4 main functionality we have to represent inside a platform for a utility. And this is basically represented here in this diagram by a puzzle of applications. And let me explain the different applications. So we have the traditional Prism or other SCADA inside at the center of this diagram, and this is the typical operation system that is already available in the majority of companies. Through this, today you can do dispatching, for example, or large DR, large solar farms, for example. But then we have the DR. This is the DR that are managed directly by the utility, whether they are in front of the meter or behind the meter. In this case, we're not concentrating on that, but this is basically DR with which the utility has a direct connection. And in this case, we have the possibility of characterize the capacity of the DR we have to interface to manage the interfaces, and we have to exert local control. For example, we don't want all the data to go back to a centralized application, then being sent back for control. When we schedule an event, then we need to be able to exert local control, even to include the preferences of the customer in that case, if this is a customer-owned DR. At this level, we have an element which is our edge node. We talked before about the edge node. How do we connect the physical asset? This is represented by this yellow logo, and here we go. An application is called OneSideThings, and which is an Intel market-ready solution. OneSideThings allows us to connect, allows us to process data, allows us to analyze data, allows us to do a forecasting of generation load conditions, for example, at 24 hours ahead. By OneSideThings Edge, we produce the warnings and notification, and we can send them directly to the SCADA, for example, in the case of large DRs, or in the case of aggregated DR. Then the characterization of the DR is also done in an application called OneSideProsumer. We also do the scheduling, and we also take care of the compensation or rewarding of the participants. The analysis is done by OneSideIntelligence. OneSideIntelligence connects to the SCADA, but also connects to the different, through the edge component, connects to the different physical assets, whether they are DR or whether they are assets like nodes in the network. OneSideIntelligence is able to produce that information. And we represented here also third-party aggregator cloud. A lot of utility, a lot of our clients have already in place policies for demand response, whether they are water heaters, for example, or they already have agreement with other aggregator like I don't know, Energy Hub or Tesla batteries. So we don't want to exclude those. This is OneSideProsumer is basically can send information to third-party cloud and receive information on the availability of the resources. Whether this information is a resource by resource or whether this information is an aggregator, that's an agreement that the utility will have to take with the third-party cloud aggregator. And we move on now. We show some of the screenshots. For example, planning a demand response event through OneSideProsumer. Of course, we have an expected curve of demand, and then we can understand how many participants we have, how much capacity we have to reduce load at a certain part of the day. And we also have the reliability parameter about this, about the available resources. We can account for the dollar for kilowatt hour of each DR, so we can stack up an offer or a cost for a particular event according to the capacity that is required. We represented here one of the screenshots, but basically it's a real-time monitoring of flexible demand. So we are able to monitor in real time what is happening, how the demand is dropping, right, and eventually take actions on a shorter time frame to compensate for some of the DR, for example, that didn't show up in an event because of communication problem. And finally, once we finish an event, we have the settling part, where we basically take into consideration all the components that make up a price, make up a cost of each of the event that we have called upon. In the case of OneSideIntelligence, we have a more graphical information, so more analytics, monitoring, for example, of distribution nodes and larger DRs. This is very important during an event, try to give information to the utility how that event is going, how the connection to the larger DRs is going on. We have the possibility to characterize each large DR and location. So we can create a navigation tree where each DR, each major DR, larger or energy intensive assets are connected to the network, and so capture the signal directly from those. We have the analysis of network performance. So we start to analyze this information may come directly from the SCADA, for example. And then we have the analysis of contribution of large DRs and clusters. So we can do an historical analysis, try to understand how to improve the next events that we have in planning. We pass here now to the other case, which is the flexible macrogrid. In this case, we have OneSide Utilities Grid. And again, we have the main component here is Prism or another SCADA, and we represented here the rest of the grid. We see again that the same element we were seeing before, the one-side thing. In this case, we're connecting everything in a microgrid is connected to an IoT gateway. So it's connected, we are able to connect and be able to get information from that particular asset and send also commands, manage the interfaces. Here we represented buildings, we represented energy storage, we represented also grid assets. This is very important because once we start to talk about a macrogrid, then we have assets which can be very different. Just the possibility to control or to send a command to a building automation system, for example, to reduce the overall load at that particular building becomes very interesting in a macrogrid where the resources can be minimal in case the macrogrid has to work under isolated condition, islanded conditions. So the entire microgrid is basically monitored and is controlled by a microgrid centralized controller. The microgrid centralized controller can be a third-party microgrid controller, for example. And the important thing that we are able to exert commands and send and receive data from all these assets through the same component, to the same software component, which is also the component that manages the interface with the microgrid controller, and is the component that can also manage the interface with the SCADA. So again, Intel market-ready solution, one-side things, a software component that goes directly in the field, and then a software component that is in a centralized application. We have one of this application in Australia, very big microgrid. As you can see, 25 different buildings, 3.5 megawatt of peak demand, 1.5 megawatt of solar installed, 1.2 megawatt hour of battery. This is actually the largest battery, the largest behind the meter battery in Australia. So pretty big, large investment sponsored by the Australian government to prove what a large macrogrid can contribute to the outer grid. In fact, the macrogrid that you see represented here has got a connection point. The Monash Smart Energy City has actually got a microgrid operator, like an entity which is registered in the Australia market to sell services and energy back to the outer grid. So there is a connection point, and there is the national electricity market. A very important experiment this has been done, starting in 2018, is reaching its conclusion. It's going to be stable, is evolving. You see that the Prism, we're now installing also operational intelligence, the software we saw before. We're also installing Prosumer over there to extend the capacity of this microgrid. So a very, very important case is a lot of information is being produced around this. A lot of knowledge is being acquired through this particular project. And our last use case is the asset performance. In this case, we want to represent switches, breakers, voltage regulator, transformer, or your CNI energy assets. It can be monitored. Particularly interesting is the fact that we can analyze data directly when data is produced. So we don't want to bring back all the information to a centralized application. We just want to bring back the information that is relevant. If everything works as usual, as expected, then there's no need to bring back the information to analyze it. However, when we can immediately spot a deviation from the expected results or the expected performance of one of these assets, then we start to stream data back to alert about that event. Here we have an application which can analyze health index, can analyze performance of assets, can basically create synthetic signals that we can then compare with the signal that are coming directly from the field, and try to understand when the deviation started from ideal condition and what is happening. The system can also spot an alert, a warning, and then be integrated with your enterprise maintenance system to send back information, for example, to create a service order for a field technician to go and see and look at the asset. For example, to send a notification to your commercial industrial customers regarding one of their major assets that is performing differently from what they expected. So it's a service that can be provided to large customers. Again, here we have one set thing. So we have the edge component, the IoT gateways based on Intel technology that can be connected to those assets and provide that information directly in the field. And with this, I wanted to take you to another question, another polling question. So which of these solutions does your organization plan to implement in 2021 and 2022? And here we have 5 different questions. One is flexible demand and peak demand management. Of course, since many of you have answered already about these two, this is could be for maybe the most common answer. One or more microgrids. We have asset performance monitoring, SCADA data analytics, so like an Historian, for example, or none of the above. So we'd like you to answer these questions, and then we'll move on with the rest of the presentation. People are voting. We have quite a number of participants today, quite a large number of participants. Wow. And we'll see now, we can comment on the results.
Okay, looks like our answers are slowing down. I am going to end the polling now and share those results.
Thank you. So we have a lot of interest for SCADA data analytics and Historian. 35% of the participants answered that's going to be one of the projects in 2021 and 2022. And then the second most is none of the above. So we need to know what that is. What are the new plans for the 21, 22, and then we have some asset performance monitoring, flexible demand, and peak management. So it's interesting. Regarding SCADA data analytics, of course, we have seen. Close this. Regarding SCADA data analytics, we have seen operational intelligence, for example, in the previous slide, and this is what we are proposing to a lot of our customers as a way of bringing data from the SCADA, but also from other systems, and be able to visualize data either in real time or large historical analysis, try to understand how to improve the performance of the operations in the network. But I now pass the word to my colleague, to Prithpal from Intel, to introduce the next topic. Prithpal, the floor is yours. Let me your slide.
Thank you very much, Giovanni.
Let's see if I can. All right, I did it. Thank you.
Okay, thank you, Giovanni, and good morning, everybody. Thanks for joining us. So I'll cover a few of the items here on the grid modernization, but think in this context of 3 things, The first thing, a big thing happening is the electrification of our transportation infrastructure. What it will mean for the grid, the more demand for the electricity or more load coming to the grid, and basically each car is equivalent to 1 house. And if every house has 2 cars, so now all of a sudden basically the load on the grid multiplied by 3 times, The second thing is the data centers. Data centers are growing rapidly. Some of the estimates are that 25% of the world electricity will be consumed by the data centers because we are moving from the brick and mortar to the digital commerce, and it will keep growing. And the third thing is a lot of push from the regulatory agencies or policymakers to use more renewable resources, focus on sustainability. So all these 3 factors lead for us to rethink how we are going to maintain, manage, and operate grid in future. So I'm going to share a few of some ideas around it. Next slide, please. So this is what is happening in the grid. Sustainability is driving the bidirectionality in the grid, but it comes with its own challenges. First, we have a large-scale penetration of renewables at the transmission level from big solar farms and wind farms, and they go up and down very quickly. So that is one challenge we face. When they go down, then automatically we have a problem with load and generation. The second thing is the large scale penetration of renewables at the edge of the grid, in which also creates another problem. One time we can have a lot of excess generation, and the second minute that can drop by 50%, and the load is being shifted back to the grid. So the continuous seesaw which is going to happen, which is going to be instability in the grid, where renewables are moving very fast up and down, and load is shifting from one direction to another direction very quickly. How do we manage this going forward? Because if we don't do anything about it, the amount of renewables which we are going to use, that's not going to be at optimum level. Then still we have to keep running those traditional power plants for the base load, because load can shift anytime back to the grid. So we'll discuss few items around it, how we can modernize the grid to optimize or increase the utilization of renewables. Next, please. So here is the 4 foundational pillars in order for us to integrate the renewables seamlessly into the grid. The first thing is to focus on modernization of automation and control. The current system which we have in the grid, especially in the substations, they are fixed feature function devices. They are designed to do one thing and only one thing. And one system does not know what the other system is doing, The second thing is, with this distributed system, our need for the security will totally change. Way we used to protect our generation facilities, that is how we are going to protect the low voltage systems also. And we need a scalable solution which can be upgraded very easily, because security threats change. And with that, we need a system which is very flexible and can be upgraded. The third thing is the deployment of applications at the edge. What is the current process we have? If we need to deploy application at the edge, what we do? Buy a box, put on a truck, send 2 guys or girls to the substation and deploy that. Then take next 8 to 12 hours, install it, commission it. Complex process, costs a lot of money. We need to change that process too. And the last thing is that how we can change the grid from a model-driven grid to a data-driven grid using the analytics. If we can collect more data at the substation, even from the south side, do some load desegregation, okay, and also use the forecast to predict how the renewables are going to behave substation by substation, feeder by feeder, and we can have a better insight into it, and we can plan our grid in an optimum way. So next slide, please. So here is the idea what we see, that the way to move forward is a software-defined system. We need to standardize the hardware for the substation market in order to optimize or optimize the access to the renewable. The best way to do is we take away the fixed feature function devices and replace them with a rack with rugged hardware in it. These are IEC 61850-3 Class 2 or ANSI 1613 certified servers. Once we have this rack of servers there, let's say we use a cluster of 3 servers, we can virtualize all automation application to it, from security applications, IT applications, to all the OT related applications. Once we start virtualizing them, the next step will be we can have aggregate all the data coming from various data points into a single database, and then apply the power of analytics, machine learning, deep learning technologies, start getting better, more insight into it, and to start turning our grid into a data-driven grid, and start getting more insight into it, and figure out a way to optimize the use of the renewables. The second piece to it, we can apply this same technology to protection and control. We can, again, virtualize all protection and control algorithms, increase reliability, redundancy, and safety of the system. Next, please. So here is an example which we is trying to show with you that if we can convert both automation and protection and control into 2 rack of servers, depending upon how many applications are, how much reliability or redundancy we need. So if we have 2 rack of servers running all these applications, and now we can start collecting the data from the south side of the grid in whether we have a storage along the feeders, we can basically optimize the use of that storage. When there's too much renewables, let that excess power go into the storage, and then when the renewables disappear, we can immediately start discharging that storage and balance the feeder. So what it will lead to? It will lead to a grid of microgrids. Each feeder will act as a microgrid, and now we start making grid a data-driven grid. We start optimizing the use of renewables in the grid, or maximizing their benefit, meeting our sustainability goals, and at the same time increasing the reliability of the grid with this new architecture. So in our work with the utilities, we found out if we move to this new architecture, it will reduce at least 50% of the devices in the substations, and also it will reduce around 76% of the operational maintenance cost. It is a win-win. So this will be a new way of managing, maintaining, and operating the grid with a lot less money, more productivity, and maximizing the use of renewables. Next, please. So we'll leave you with a thought from the Intel founder, Robert Noyce, that don't be encumbered by history, go off and do something wonderful. And I think this is an opportunity for us to all get together and do a wonderful thing to maximize the use of the renewables, to meet our sustainability goals and make the planet more cleaner. Thank you very much for joining us today.
Thank you, Pedro. Thank you very much for your participation. Thank you, Joe, for your participation. We're now going to get some questions from the audience. I'm trying to move to the next slide, but I don't seem to be able to. There it is. Now we have a colleague, John Reuters, who will ask the questions that we have received.
Yeah, thanks.
Hi, John.
Great. Yes, great job, everyone. Very informative and lots of good stuff. So, and we have some questions coming in from the audience. The first one is from Intel, for Intel. So either Prithpal or Joe, feel free to answer. But has Intel recently been involved in a substation virtualization initiative at any utilities? If you want to take that.
Yes, this is Prithpal. Yes, so we have worked with a couple of utilities here in US and also in Europe. So we are working on 3 areas. First area was that virtualizing the automation piece. That's what kind of picture I showed you. And so that was the first goal, virtualize the complete automation piece. The second thing we work on, virtualizing the protection and control system. We build, working with the ecosystem and utilities, we build 2 systems right now. They're deployed at 2 utilities. They are testing basically performance of the system. How can we use a standard rugged hardware in a virtualization platform and virtualize the real-time deterministic protection and control algorithms? So that's a second thing. And the third thing, we are working with the utilities in Europe to virtualize the secondary substation. And so that project is in the process with the ecosystem partners. We are going to have that the POC, proof of concept, get deployed probably around December timeframe. So we'll share the results of all these activities in upcoming webinars, probably early next year.
Fantastic. Thank you, Prithpal. Have another one. Gio, you can probably start the answer on this one. So where can a utility start from for implementing flexible demand? So where can they start?
Well, thanks for the question. But one of the examples that I was showing probably was the microgrid example, is where we started with in the Monash Smart City. We basically had to connect large buildings. We basically had to connect large buildings. Sorry, that wasn't showing my video. Large building automation systems, and to be able to control that part of demand. So we got together with the client and we said, okay, what can we control? We understand what the interface would have been with one of the intelligent nodes, and we started to get data from there and send set points. And it was for example, something that was pretty straightforward, because we could actually manage quite a large amount of load. We could actually shift a large amount of load without having to install a lot of hardware in the field. We started with connecting the inverters of the large solar installation, and again we tried to understand what the interface was over there, and we started to gather the data, and we were able also to send commands to the inverters, and that was of course allowing us to control maybe the generation, not so much the demand in that sense, but of course the generation was directly connected to. And so from a flexible demand point of view, having large loads in the network and be able to control those, or at least send set points, is where a customer can start from.
Okay, great. So we had another question. I'm not sure when it came in during the presentation, so I'm not sure the context behind it, but it just was simply, what is the communication protocol used? I know, Prithpal, you would answer certainly for the virtualization substation portion that you guys are leveraging 61850. But I'm not sure if that it may have come in during Giovanni's portion. Gio, do you want to just comment on the different protocols that can also be used when talking about flexible demand and interacting with these various edge devices and DERs?
So our experience is that, well, in the absence, since many times we have in front end a brownfield solution, so there's something that's already in the field. We find that Modbus, for example, it's one of the protocols that we mostly have used. Modbus RTU, Modbus for IP also. So we were able to use those. One of the things we have in the edge piece, so on the one side things that I was showing, is the software component is actually a protocol manager that allows us to directly implement. For example, if you find a proprietary protocol and to implement that protocol and to communicate with that particular controller or build the automation system, for example. Or also allows us to deploy, for example, component by third parties. For example, in one project we were doing an offer for, we had to bring in a Modbus Sunspec, and so we just took one of the component which was already available in the market, and we deployed as a software component in the edge, and that will allow us to to use that protocol also. So there's a number of things that can be implemented depending on which technology we have out there.
Very good. Prithpal, did you want to add on your portion, the protocol that you guys were using for your virtual substation?
Yeah, so I think it's a complex question. Let me say so I don't understand what is the context of in the question. So if we want to talk between the substation and the utilities control center, okay, so I think the IEC 61850 is kind of becoming the standard there as world is moving towards the more substation digitalization. But is a room to increase, move to some better system? Yes, there is a discussions around it. Can we use OPC UA? That's or DDS. So that kind of discussions are there to basically to move to a standardized, universal standardized protocol versus stick to a industry specific. So those are the kind of discussions are out there. But inside the substation, if we are talking about between the merging units and these new servers, and yes, it is basically IEC 61850. I think that's where the things are kind of standardizing. And also looking at somebody asking the other questions, it needs to be a redundant system or reliable system. So using the PRP, so parallel protocol redundancy, so those kind of technologies to make sure that we meet the needs of control systems. So all those kind of things which are done today, and so we are supporting it. And one thing additional what we are doing in this area, especially in protection and control, we have got the technology which called SRIOV, which is the virtualization of the NIC, so which is very commonly used in the data center world. And we are bringing that technology into the substations to building the next generation networking interface, which has a HSR, PRP, which are traditionally used in this industry, and add this NIC virtualization technologies into it, so to increase the reliability, and so system can meet all those real-time deterministic requirements.
Okay, great. So just encourage everyone, we still have a few more minutes. So if you have any questions, use the Q&A and try to get those in. We've got a couple more here to go through. So Joe started out the presentation talking about how utilities are starting to compile a tremendous amount of data and they really just don't know what to do with all of it. And it sounds like they'll kind of figure it out on the way. So how can Minsite ACS and Intel, how can you help customers design a way to deal with that data and work with that data architecture? And I can get it started, and then Giovanni and any Prithpal or anybody else wants to jump in, they can certainly do so. So I would say that first of all, traditionally a lot of data has been very siloed in the utility world. So you have a particular business case, you have a particular need for that data, and it's collected, and it's not even thought about sharing amongst a lot of different departments and stakeholders within the utilities. So it really depends. We have a lot of different data sources now, all the way to the grid edge, running grid edge computing, like using Intel chipset, edge processing capabilities. But then that data needs to, there may be multiple different ways for that data to be processed and utilized throughout the utility, and it can't be as siloed. So certainly one thing is that we are moving towards at Minsite ACS is having one platform that can ingest all that data, have that data in one location with a singular, similar data model, and then be able to use that in multiple different business cases throughout the utility across many different departments. Giovanni, if you want to add on to that, or anyone from Intel.
Sure, this is Joe from Intel, and I can add on to that a little bit. Intel has internal resources that we can, bring to any utility engagement, and we offer these resources free of charge. So if you're talking about developing a architecture, reference design, or just a flow of data information and how you would integrate your mini data centers on the edge to your data centers in the home office and utility, Intel can bring those resources to bear. And we would work in conjunction with Minsait ACS to do that. Sorry, Gio, sound like you wanted to add on.
No, I'm absolutely. Yeah, and again, we've been working, luckily enough, with Intel for now a number of years, and it's been in a very, very interesting journey. We started in, I believe, in 2014. I was still in Australia. We were visiting clients around, and it was always there's always been a lot of collaboration. And in some customers, we actually done a lot of work together and came up with very, very brilliant solutions together. So it's been a nice journey. Yes, it's having a partner like Intel has always been very helpful to scope a solution for our customers. Great technology behind Intel, great people to work with, and we've been able to really deliver something really interesting. Not last the example that one of the example in Europe that Prithpal was talking about before in his presentation. So yes, starting from just scoping high level architecture and then finding a solution also for gateways, for example, or with one of the partner that produces Intel based technology. Is always a great possibility to innovate in the utilities.
Okay, great. One more specific to Intel. So either Joe or Prithpal, how is Intel collaborating with utilities to ease the path to more virtualization?
Okay, so this is Prithpal. So let me try to answer. So what we have done is working with the utilities to build first a reference architecture. Okay, so doing the reference architecture, okay, that defines the direction utilities want to go, the problem it is solving. So Intel is investing into that kind of approach first, working very closely with the utilities to build a reference architecture. And then the next step is how do we implement the reference architecture? That's where Intel goes and works, brings the ecosystem with it, the hardware vendors, the software vendors, the integration partners like ACS. We work all together so utilities, okay, how can we implement this reference architecture? Once we implement it, prove it, validate it, test it, look at the ROI data. So then utilities say, so, okay, now it makes sense. And then that is how we can drive the market. So our goal is to collaborate, innovate, and accelerate, working with the utilities. And Intel does not charge anything for its services for the utilities. We work very closely with the utilities to help them go through that process. Because seeing is believing. If you don't go build a system, test, validate, and prove it, you won't know the value of it. And that's how Intel comes and works closely with the utilities. Joe, you like to add anything to it?
Yes, I would. Some people might be thinking, is there a formal process for this? And Intel has instituted what we call coalitions around various innovations for utilities. One of them is actually called the Virtual Protection Relay Coalition, and this is already taking off in Europe, where we formed a coalition. We're forming one now in the United States, and these coalitions contain various utilities, OEMs, software providers, and so forth, and SIs. And what we try to do is bring together sort of a critical mass of utilities to influence these other ecosystem partners to build something that the utilities are driving and that the utilities are interested in. And these coalitions are very powerful. And if any of the utilities on the line would like to talk about that, please give me a shout.
Okay, great. Well, it looks like we're running out of time here. Appreciate all the great questions. If there were any questions that we didn't get to, we'll be certain to answer those offline. Be sure to join us on the upcoming sessions throughout the week, and hope everybody's doing great. Delane, I'll turn it over to you.
Yeah, I just wanted to let everybody know we do have another session at 3:30 p.m. today. Hey, IT, this is OT. Let's get to know each other better, and you can get information for that at acspower.com/conference2020. Thanks for joining us today, everybody. Have a good day.
Thank you.
You.
Thank you.